Now suppose you have a system of m linear equations in n variables. It's denoted by a sub 1 x1 plus a sub 1 2 x sub 2 plus a sub 1 3 x sub 3 plus the rest of the middle terms, so linear combination, a sub 1n xn equals to b sub 1. This is your very first equation in n variables. The second equation is denoted by a sub 2 1 x1 plus a sub 2 and 2 x2 a sub 2 3 x3 plus a sub 2n xn equals to b sub 2. We continue this process. This is our second equation. The third equation, a sub 3 1 x1 plus a sub 3 2 x2 plus a sub 3 and 3 x3 plus the rest of the terms, a sub 3n xn equals to b sub 3. Again, we continue this process. We have more equations involved here. For simplicity, I'm just going to write down the last equation, a sub m1 x1 plus a sub m2 x2 a sub m3 x3 plus the rest of the terms, a sub mn xn equals to b sub m. You saw these types of equations in algebra before. For example, in algebra, you had equation x plus y plus z equals to 1. Then you had 2x plus 3y plus z equals to 5. And another equation, negative x minus 2y plus z equals to, for example, a half. In algebra, they usually ask you to solve system of equations. Here you have 3 variables and you have 3 equations. You can convert these into a system of linear equations. In this scenario, a sub 1 1 is 1, a sub 1 2 is 1, a sub 1 3 is 1, and b1 is 1. Related to the first equation, these are the coefficients that we have here. Then in the second equation, a sub 2 1 is 2, a sub 2 2 is 3, a sub 2 3 is equal to 1, and b sub 2 is 5. And for the last equation, a sub 3 1 is negative 1, a sub 3 2 is negative 2, a sub 3 3 is 1, and the constant term is a half. The same process as we did before for algebra. We're just generalizing the idea and having more nice representation here. In this scenario, if you can solve this system of linear equations or this linear system, a solution of a linear system, as you can see in the above, is a sequence of numbers. Like S sub 1, S sub 2, S sub 3, and S sub n, that is a solution of each one of these equations. For example, take a look at this system. Here you have 3x sub 1 plus 2x sub 2 equals to 3, and you have minus x sub 1 plus x sub 2 equals to 4. Well, If you just solve the very first equation without considering the second equation, you might say that, hey, x1 equals to 1 and x2 equals to 0 is a solution for the first equation. But is it the solution for the second equation? If I plug in -1 here and 0, -1 is not equal to 4. You have a solution for the first equation, but not for the second equation. When you're solving a system, you need to solve for both of them. In algebra, we had 3x plus 2y equals to 3, and you had minus x plus y equals to 4, and you graph these two lines, and you find the intersection between them. For example, here you have Desmos, 3x plus 2y equals to 3, and the second equation, minus x plus y equals to 4. Just basic algebra. So as you can see, you have an intersection between these two lines, and the point of intersection is -1 and 3. So you can easily conclude that -1 and 3 is the solution for this system of equations. You're basically doing the same thing. You're generalizing the idea from basic algebra into more generalized form.